In this video, I'll describe preparing for multiple linear regression. I will introduce a sample problem, then I'll work through the process of limiting some variables that are unlikely to be good predictors, then I'll derive the data partitions. The example I will use is that of predicting the price of used Toyota Corollas from a set of facts. We started out with 40 variables. The price is our output variable. I've already taken about 14 of these variables that are not really predictive and excluded them. And now we can look at the remaining 26 and make some decisions. One good thing to look at is how the correlations are between the input variables and the output variables. And we can see along this row where I have highlighted some of these so that they can be seen, and right-clicked on them in VisMiner so that they're seeable. Some have very strong correlations, like this has age in years, has a negative correlation with price. So does kilometers on the odometer. And some are like cylinders. Every one of these Toyota Corollas has 4 cylinders, so this is really not helpful, and it's showing it here that they're all the same. If they're all the same, they can't differentially help us price a car, so I'm going to remove that. And so let's just talk about these. We have anti-lock brakes, age in years, whether it has air conditioning, whether it's an automatic or not. That has a really low correlation. I'm going to leave it in there just to see, but it's probably not going to help us with our pricing. Whether it has automatic air conditioning, how many cc's, whether it has central locks, does color matter? This is an interesting one. There are about 20 different colors in the data set. I've already done some looking to see if colors are associated with helping us predict the price. Turns out they're not, so I'm going to exclude that one from the data set. Fuel type is in there, which is petroleum, compressed natural gas, or diesel. Even though it has a low correlation, we're going to leave that in there because it will let us look at examples of dummy variables. And we have how many gears it has, the guarantee period, how many horsepower it has, kilometers on the odometer, whether it has metallic paint, whether it has metallic rims, the manufacturer guarantee, mist lamps, power steering. Again, that has low correlation, so it may not be helping us, but we'll keep it in there, and it may just end up that we end up throwing this one out. Power windows, whether it's a sports model, whether it has a tow bar, and price. One particular one I want to look at is central locks, which has a very high positive correlation with power windows. And the way cars are created is that usually central locks and power windows, the controllers for those are in the doors. And so they tend to come as a bundle. If you get central locks, you also get power windows. And this is evidenced here by this very high correlation between these two possible predictors. In effect, it's two different measures of the very same thing. And so this is an example where we're going to want to get rid of one of those so it doesn't confuse the model. If we look down here, we can see that this has a correlation with the price of 0.343. If we go over to power windows, it's 3.357, a bit higher correlation with our outcome variable. So we'll keep that one. So I'm going to go up and remove central locks. So at this point, we're down to about 25 remaining variables. A few of them have low correlations with price, but there are no high correlations remaining up here between independent variables that can confuse the model. And now I'm going to create a subset and make a smaller set. Fewer variables, and create that. Now I'll close this. And now we have the model which has fewer variables, and we've done a pre-scrub so that there are less variables in there. Now we're down to 22 columns. And so once we're down at this point, we can go ahead and partition the data into the types. And so let's do that now. So I'm going to right click on this and create Derived Data Set. This allows us to partition the data, and also if we wanted to further select out variables or eliminate variables, we just wouldn't check them. Well, we're going to check them all in this case, and I'll just call this Toyota PART for partition. And then I need to come down here and select some of these that are going to be held out for validation set. I'll say 436 is going to be held out, and then click up here and that will subtract so that there's 1,000 for training, 436 for validation. I'm going to fix the random sequence just so that if you do this exercise you'll get the answers the same as I do. If I don't fix this, then we every time we go and partition the data, it takes a different random sample and might give us slightly different results. And so just to make it easier for your comparison purposes, I'm going to fix the random sequence.